Yes, hello my dear students. Here we are in another video, and today in this video we're going to talk about generating sequences. Well, basically we are going to talk about linear sequence and nonlinear sequence, but during this session we will face like variety of questions about sequences. That's why I want you to stay with me and follow me, and then be patient. We are going to solve like different types of questions regarding to sequence. Well, the first thing that you need to know about sequence is like a set of like terms. These terms can be numbers or anything else. That there might be a relation between them, or there may not be. All right. So here, let's first like define these two type of sequence: linear sequence and nonlinear sequence. In a linear sequence, the terms increased or decreased by the same amount each time. For example, if you take a look at this sequence, let's say 3, 6, 9, 12, 15, and it goes on like this. So look at the difference. As you can see, this sequence is increasing by an amount. All right. So the difference between these two terms is 3. The difference between these two is 3. The difference between these two is 3. The difference between these two is 3. And it goes on like this. That's why we call this sequence a linear sequence. All right. So that is the meaning of linear sequence according to the name. So linearly it changed. So the difference between each two terms is the same with others. But in nonlinear sequence, the story is completely different, which means the difference are different. For example, take a look at this sequence: 1, 4, 10, 23, and it goes on like this. So the difference between these two is 3, the difference between these two is 6, the difference between these two is 13. So they are not equal to each other. That's why we call this kind of sequence a non-linear sequence. It's not linear. Perfect. So that is the meaning of linear sequence and nonlinear sequence. So directly, I want you to come with me and let's go through the questions here. I'm not going to solve this work example because the solution is given, so you may just realize like what the book has done during this question. So let's just go to the exercises and let's start from the first exercise. It says, write whether each sequence is linear or nonlinear. So, like 9 different sequences are given from A to I, and we are going to just solve, like find out like which one is linear and which one is nonlinear. So I might leave some of them for you guys in order to deal with them by yourself. So first of all, here in A, so I'm going to just choose them randomly. I will solve A, C, E, G, H, and I. And I'm pretty sure I choose like the best ones. So I hope that you can guys realize and do the rest by yourself according to these notes that I'm going to give you during these 6 questions. So A, the difference between 11 and 15. The difference between 11 and 15, it is 4. Between 15 and 19, it is 4. Between 19 and 23, it is 4. And it goes on with this difference between each two terms. That's why we call this one linear. So we can just write L, that stands for linear. So I will leave B for you guys. How about C? So the difference between 4 and 5 is 1. 5 and 7 it is 2. 7 and 10 it's 3. So 10 and 14 it is 4. And as you can see, the differences are not the same. That's why we call this one non-linear. So you can write NL, which is non-linear. How about D? So D for you guys, E. 100 became 95, so it is a decreasing sequence. The difference is 5 subtracted by 5. 95 became 90, which is again subtracted by 5. 90 became 85, so decreased by 5. And 85 decreased by 5, so it became 80. So as you can see, the differences between each two terms are the same. That's why we call this sequence non-linear sequence. Perfect. How about G? Guys, G, H, I just choose them on purpose because always during the questions, during the exercises, that it includes like parts. The last ones are like kind of difficult to the students. That's why I choose them in order to not complain me. So 0.5 became 1, 1 became 1.5, and 1.5 became 2, 2 became 2.5. Clearly, you can guys see that the difference between each two terms is 0.5. So, and our sequence is kind of like increasing system. That's why we can see that, we can find out that the difference between each two terms is 0.5. So since the difference is the same amount, we call this sequence linear sequence. How about H, guys? In H, we are dealing with mixed numbers. So 3/2, look, 3.5, it became 5.5. So the difference between these two is 2. All right. How about the next one? The next one is 9.5. So 5 to 9 and 5/2 to 9/2. It is 4 if you go and check it. So 9/2 minus 5/2 will give us 4. So as you can see, since the difference between these two terms are not the same, these two terms are not the same, we call this sequence nonlinear sequence. Let's just check one more difference. 17, 1 over 2. So from 9 to 17, 9/2 to 17/2. What I mean by that, so imagine guys, if you do it like in decimal form, 17.5 minus 9.5. So the difference between these is equal to 17 minus 9, 8. So here the difference is 8, as you can see. It's not the same with the previous two differences. That's why we call this one generally like nonlinear sequence. How about the last one, guys? So 20 became, I just want to make sure that you guys can see the questions. Yeah. So 20 minus 12, it is 8. 12 minus 4, it is 8. 4 minus minus 4, so it is 8. And negative 4 minus negative 12. Well, this one is going to become 12. Negative 4 plus 12. Sorry, it is 8. So the differences are the same between each two terms. That's why we call this sequence as well a linear sequence. It's L. So as I already mentioned, L stands for linear sequence. That was about the first exercise. The second exercise, guys, there is a table. And this table, it asks us to find like write the first three terms of each of these sequences. So first we need to find out like three terms of each sequence. In each row or in our table there is a sequence that it gave us the first term and its term to term rule. Well, term to term rule is just like a rule that it's actually give us the other terms of this given sequence. So for example here, since there is no enough space here, so I would like to write the solution in this A4. So the first term is 3.5. Again, I'm going to choose like some of them. So I will choose A, C, E, and F. Then I will leave B and D for you guys. So 3.5, so it says add 0.7. So 3.5 plus 7, it is equal to 4.7. Perfect. How about 4.2 plus 4.2 plus 7, 0.7, sorry, 0.7. So 4.2 plus 0.7, it is equal to 4.9. And 4.9 plus 0.7 again, it is equal to 5.6. Perfect. So the question asks us to write the first three terms, while we actually found like four terms of this sequence. Here are the terms. How about the C? So I will leave B. B is easy, honestly, guys. You are lucky that I choose always the hard one. So C is 4 1 over 3. That is the first term, by the way. It says subtracted by 2 over 3. So 4 1 over 3 minus 2 over 3. Well, in previous videos, I actually um, post a video regarding to the subtraction of fractions. You can just go to that video and find it out how do we subtract them. Well, first of all, we need to turn this mixed number into a fraction. 3 times 4, 12 plus 1, 13 over 3 minus 2 over 3. So fortunately, the denominators are the same. So just subtract the numerators. 13 minus 2. Will it give us 11 over 3? All right. So if you just turn it to mixed number again, so we are going to get 3 2 over 3. So the second term is 3 2 over 3. So here again 3 2 over 3 minus, because the term to term rule said that subtracted by 2 over 3. So subtracted by 2 over 3, we are going to get, well, 3 2 over 3 was 11 over 3 minus 2 over 3. Well, we are going to get 11 minus 2, 9 over 3. Well, if you simplify it, it's going to give us 3. So the third term of this sequence is equal to 3. I hope you guys can understand what is going on in this question. Well, the first term is given, and it asks us only to find the first three terms. Since the video is going to become longer, I will just choose F. So I will leave E as well for you guys. So let's just deal with F. The first term is 1. Then the term to term rule said that multiply it by 3. So 1 multiplied by 3, 3. Then subtract by half, which is 2.5. All right. So I will just write the terms in decimal form. 2.5 multiplied by 3, it's like 7.5 minus half. Well, it's give us 7. All right. You can just go and check it. Times 3 subtracted by half. So 1 times 3, 3 minus half, 2.5. 2.5 again multiplied by 3, 7.5, and minus half, well, it is 7. So in the next question, cards A to D show term-to-term rules. Cards I to 4 show sequences that all have a first term of 3. So let's just match them quickly. Square then add 1. So 3 plus 1, 6, 4, 4. Now, first of all, okay. 3 squared, 9, plus 1, 10. It's not this one. It is this one. Okay. Then 10 square, 100. Add 101. So these two cards are going to match each other, A and 3. So we can write A for here. The second one, add 1. So 3 plus 1. Why do I use 3? Because here it says the first term for each one of them is 3. That's why I always choose 3 for this question. So 3 plus 1, 4. 4 square, 16. 16, 16, 8, 4. So here is the answer. No need to check the other term. By the way, if you want to check it, 16 plus 1, 17. 17 squared is 289. Be 100% sure. Card C says square it. So 3 squared, 9. Minus 1, 8, which is C here. And finally, subtract 1, 3 minus 1, 2. 2 squared, 4. So here is it. B. Question 4 is somehow the same with question 2. That's why I will just solve two of them. Well, A and C. I will solve A and T. A is first term is 4. Term to term rule is squared. So 4 squared. Let's just write the first term. 4 squared. 16 minus 11, 5. 5 squared, 25, minus 11, it is 14. And I guess it asks for the first three terms. So here are the first three terms. The next term, guys, as a homework, I will just leave it for you. 14 squared, blah, blah, minus 11. So go and find it out and write it down in the comment. Don't forget it. First term is 0 in part D. Here we are in page 195. Section 9.1 regarding to generating sequences. Question 4, part D. First term is 0. All right. Term to term rule is add 3. 0 plus 3, 3. Then square it. Well, it is 9. 9 plus 3, 12. 12 square, 144. Perfect. Well, question 5 is think like a mathematician. From the beginning of this series of these videos, I already mentioned that I'm not going to solve things like a mathematician in order to save time for the videos. So here is a very complicated questions based on my experience that I experienced it with my students in the class. Question 6 is a kind of challenging question. It says copy these linear sequences. Remember, it said that linear sequence, so it means all these 4 sequences are linear, and fill in the missing terms. So there are some missing terms, we have to fill them. All right. The first one, so I will solve A and again D. So I will leave B and C for you guys. So A is, let me bring back my paper. So there is a sequence with these terms: 2, 3, 2 over 7, a missing one, then 5, 6 over 7, a missing one, then the other 2 terms. First of all, we need to find it out whether our sequence is increasing or decreasing. So obviously this one is increasing because 2 became 3 and something. So, and it is increasing. That's why we need to find the difference between these two. And since it is linear, so added to this one, you will get this. Added to this one, you will get this missing part. So first of all, 3, 2 over 7. 3, 2 over 7 minus 2. Since it is increasing, so always the second term minus the first one. But if it is decreasing, vice versa. We will just see it. Yeah, we have got it in part D. So here it has a denominator of 1, so change this one to a fraction. 7 times 3, 21, plus 2, 23 over 7, minus 2 over 1. All right, so let's just deal with this one. Multiply this by 1, let's say, which is itself. Multiply this one by 7. Let's see what we are going to get. 23 over 7 minus 14 over 7. So 23 minus 14, it is equal to 9 over 7. Well, 9 over 7, if you just turn it to a mixed number, we are going to get 1, 2 over 7. So this is the amount of the difference between each two terms in this linear sequence. So in order to get the third term, we have to add 1 over 2 over 7 that we got it here to the second term to get the third one. Like how? Just follow me. My plus 1 2 over 7. So 3 plus 1 4, 2 plus 2 4 over 7. That is the third term. So 4 over 7. And here in the fifth place, we have 5 6 over 7 plus that difference, that amount of difference that we have got, we have to add it to each term to get the next one. So 1 2 over 7. Perfect. So as you can see, 5 plus 1, 6. 6 plus 2, 8 over 7. All right. Still, we can simplify this one. So in 8, how many 7 do we have? 1 over 7. So 6 plus 1, it's equal to 7. 1 over 7. So here is equal to 7. 1 over 7. Perfect. In part D, again, we need to find out the difference between two terms that are given. So here the difference between these two terms is equal to, since the sequence is decreasing, so we have to find the first one minus the second one, which is 18.6 minus 12.4. So let's just find this difference. 6 minus 4, 2. 8 minus 2, 6. 1 minus 1, 0. We are not going to write it down. So each term decreased by 6.2. So here 12.4. 12.4 minus 6.2. 4 minus 2, 2. 12 minus 6 is equal to 6. So the next term is 6.2. 6.2 minus itself, so it's going to give us 0. How about the first two? So here we have to add, we have to act vice versa in order to get the previous term of 18.6. So 18.6 plus 6.2, well, we are going to get 6 plus 2, 8. 8 plus 6, 14. 4, 1, and 2. So here we have got 24.8. Now 24.8 plus again 6.2. That 6.2 is the amount of difference between each two terms. So 8 plus 2, 10, 0, 1. 1 plus 4, 5, 5 plus 6, 11, 1, and 31. So the first term in this sequence is 31. Perfect. I hope you guys can understand what is going on and how am I doing these kind of questions. First of all, you have to find the difference between two executive terms. Then realize whether the sequence is increasing or decreasing. If it is increasing, so the second term minus the first one will give you the difference. But if it is decreasing, the first one minus the second one will give you the difference. Perfect. So the first three terms of a sequence are 2, 10, and 106. Which of these cards A, B, and C shows the correct 10 to 10 rule for this sequence? Let's just find it out. So 2, if we cube it, it's equal to 8 plus 2, 10. So up to now it is correct. But 10 cubed is 1000 plus 2, 1002. So that one is not a correct answer. 2 multiplied by 7, 14. Minus 4, 10. Correct. 10 multiplied by 7, 70. Minus 4, 64. It's not correct. How about this one? 2 squared 4 plus 6, 10. 10 square 100 plus 606, which is this one. And part beta, which is the first term in the sequence to be greater than 1 million. As you can see, we are in part B, which is the first term in this sequence to be greater than 1 million. So basically, we need to find out in which term this sequence is going to give us a term which is greater than 1 million. So fourth term is like 106 square. So 106 square means 106 times 106. Let's just do this one. 36, 6 times 0, 3, 6 times 1, 6. So 0, 0, 0, 0, 2, 0, and 106. So here we are gonna get 12, 1, 1. So 11,236 plus 6. Well, we are gonna get 11,242, which is fourth. So that is the fourth term, which is a number less than 1 million. So in the next term, which is the fifth term, this number multiplied by itself will give us 100%, like 1 million, more than 1 million actually. And plus 6, it will be definitely greater than 1 million. That's why 11,242 multiplied by itself will give us a number greater than 1 million. So let's just do it here. Let's just do it here on calculator, because the number is somehow big. So 11,242 times 11,242 will give us, as you can see, it's a number bigger than 1 million, 126 millions. So that's enough for us to get the answer of this question. In the fifth term, we are going to get a number. It says which is the first term in this sequence to be greater than 1 million. Well, the answer is fifth term. Question 8 is actually similar with question 4 and question 2. That's why I'm going to just solve one part of it, which is part D. So part D, it says term to term rule is subtracted 10, subtracted 15, subtracted 20. So we are going to get this as the term. So the first term is 100. So 100 subtracted by 10, it's 90. 90 subtracted by 15, well, it is 75. 75 subtracted by 20, well, it is 55, and it goes on like this. These are the terms of this sequence. And question 9 is think like a mathematician. Question 10, again, the first term is given and term to term rule as well. So I will just solve part C. So in part C, it says first term is 2. Great. Term to term rule is power 4 and subtracted by 12. So 2 to the power of 4, it is 16. 16 minus 12, it is 4. 4 powered by 4, it is equal to 256. If I'm not mistaken, it is 256, because 4 to the power of 3 is 64. 64 times 4, it is 256. Yes, 256. Sorry, minus 12. So 256 minus 12, 244. These are, so I'm going to just write it here nicely. The first term is 2 to the power of 4. 16 minus 12, 4. 4 to the power of 4, 256 minus 12, it says subtracted 12, so 244. These are the first three terms, and it asks actually for the first three terms. Question 11, the sixth term of a sequence is 486. The term-to-term rule is multiplied by 3. What is the third term of the sequence? The answer is here. The third term is sixth term divided by 2, 486. The thing that we see here is it says that is Tanya's method correct? Honestly, it is definitely wrong, because we cannot say that randomly the third term is the half of the sixth term. We have to take the vice versa rule of the term to term rule in order to get the previous term. For example, here the sixth term is 486. So in order to get like fifth term, we need to multiply it by 2. All right. So for example, here we have like 486. Wait a second. Sorry. It says multiply by 3. So the term to term rule is multiply by 3. So we have to divide by 3 to get the fifth term. Yes. 486 divided by 3, it is equal to 162. That is the fifth term, guys. And to get the fourth term, we need to divide it by 3. Guys, again, I'm going to mention this point that in order to get the previous term, we need to go vice versa of the term to term rule. So here term to term rule is multiply by 3. So we are going to divide it by 3 in order to get the previous term. So the fourth term is 162, again divided by 3. So here we are going to get 54. All right. Then the third term is 54 divided by 3. It is equal to 18. So as you can see, the third term is 18, not 243. Therefore, Tanya's method is incorrect. Here it says in question 12, which is the last question that I'm going to solve for you. Question 13, I will leave it for you because the ideas are the same. So question 12 is the fifth term of a sequence is 11.5. So the fifth term of a sequence is 11.5. The term to term rule is divide by 2 and add 6. As I already mentioned, in order to get the previous term, we have to go opposite of the term to terms rule. So here it says divided by 2, we are going to multiply by 2 and then subtracted by 6. Let's see what we are going to get here. We have to check it first. So 11.5, it says divided by 2, so we are going to multiply it by 2. 11.5 multiplied by 2, 23. Minus 6, 23 minus 6, 17. So the fourth term is 17. Great. And the third term is, it asks for what? Let's see, the fifth term is this one. So show that the second term in the sequence is 8. Let's see the second term. So the third one, let's just find it out. The third term is 17 multiply 17 multiplied by 2 wait, since the sequence is here, as I can see, there is a small mistake, so I'm sorry about it. Let's just solve it again. So as the question said, the fifth term is 11.5. Perfect. And the term to term rule, term to term rule is, it says divided by 2, then add 6. So first we need to like subtract it by 6 and then multiply it by 2. This is how we act oppositely. So 11.5, since it says that show that the second term is in this sequence is 8, we have to get 8 in the second one. So in the fourth term, we are going to find out like 11.5 minus 6 multiplied by 2. The opposite of 6 is negative 6. The opposite of division is multiply by 2. 11.5 minus 6, it's 5.5 times 2, it is 11. So the fourth term is 11. How about the third one? The third term is, so 11 minus 6 multiplied by 2. So 11 minus 6 is 5. Multiplied by 2, it is 10. And the second, finally, the second term is 10 minus 6 multiplied by 2. 10 minus 6 is 4. 4 times 2, 8. As you can see, the second term, we just show that it is equal to 8. Guys, I hope that you understood these questions. Honestly, the questions of sequences like are kind of like challenging and a little bit complicated, but we have to be careful. We have to like understand the title of the question, then we have to go on. So question 13, it asks the fourth term of a sequence is 116. The fourth term is 116. All right. The term to term rule is square and subtract 5. So we have to add 5. Then what is the inverse of square? Taking square root. All right. So in order to get the previous one, so the third term is, since it says like subtracted by, look guys, here is the question. It says square and subtracted 5. So 5, since it says subtracted, we should add it, add 5. 116 plus 5, it is 121. If we take the inverse of square, so it is square root, take the square root of 121, it will give us 11. Then again, in order to find the second one, the second term is 11 plus 5, 16. The square root of 16, it is 4. And finally, the first term is 4 plus 5, 9. Take the square root of 9, it is 3. So the first term of this sequence must be 3. Again, I'm going to repeat it. In order to get the previous term of a sequence, we have to like act oppositely of the term to the given term to term rule in order to gain the previous term. Again, I'm going to tell you that I hope that you guys understand the solution of these questions. In case if you have any question, you can just write it in the comment part, and take care. Have a nice